Hi everyone, my name is Kang Dong-hee. Today I'll present about ChestNet radiologist level pneumonia detection on chest X-ray with deep learning. I think this paper is well organized and easy to understand for the general public. First, introduction. Research background. More than 1 million adults are hospitalized with pneumonia, and around 50,000 die from this disease pneumonia every year in the US alone. Chest X-ray are currently the best available method for diagnosis pneumonia. Research purpose. Detecting pneumonia in chest radiography can be difficult for radiologists because the appearance of pneumonia in X-ray image is often vague or can overlap with other diagnoses and can mimic many other benign abnormalities. These discrepancies caused considerable variability among radiologists in the diagnosis of pneumonia. Research topic. The model can automatically detect pneumonia from chest X-ray at levels exceeding practicing radiologists. Method of a ChestNet. The pneumonia detection task is a binary classification problem, where the input is a frontal view chest X-ray image, and the output is a binary labels, indicating the absence or presence of pneumonia. Also optimized the weighted binary cross-entropy loss. Model architecture and training. ChestNet is a 121-layer dense convolutional network. They replace the final fully connected layer with one that has a single output, after which apply a sigmoid nonlinearity. The weight of the network are initialized with the weight from a model pre-trained on ImageNet. The network is trained end-to-end using ADAM with standard parameters. They trained the model using mini batches of size 16, initial learning rate of 0.001. Data. I think data quality is excellent. They use the chest X-ray 14 dataset, which contains about 100,000 frontal view X-ray images of 30,000 unique patients, and they marked at 14 different thoracic pathology labels. The label images that have pneumonia as one of the annotated pathologies as positive example, and label or other images as negative example. They randomly split the dataset into training, validation, test set. There is no patient overlap between these sets. test set. They collected a test set of 420 frontal chest X-rays. The radiologists had 4, 7, 25, and 28 years of experience, and radiologists did not have access to any patient information or knowledge of disease prevalence in the data. Comparison. They assessed the performance of both radiologists and ChestNet on the test set for the pneumonia detection task. They have 4 labels from 4 practicing radiologists and 1 label from ChestNet. They compute the F1 score for each individual radiologist and for ChestNet. They use the bootstrap to construct 95% bootstrap confidence intervals, calculating the average F1 score for both the radiologist and ChestNet. They compare radiologists and model on the F1 matrix, which is the harmonic average of the precision and record. They referred the 4 resulting F1 score for each radiologist and for the ChestNet along with average F1 across the radiologist. ChestNet achieved an F1 score of 0.935 and higher than the radiologist average of 0.387. They used the bootstrap to find that the difference in performance is statistically significant. Limitations. Only frontal radiography were presented to the radiologist and model during diagnosis, but it has been shown that up to 15% of accurate diagnosis require the lateral view. They expect that this setup provides a conservative estimate of performance. Neither the model nor the radiologist were not permitted to use patient history, which has been shown to decrease radiologist diagnostic performance in interpreting chest radiography. Also, they compared the performance about people studies using same data set. They expanded the algorithm to classify multiple thoracic pathologies. The ChestNet outperformed the best published result on all 14 pathologies in the chest X-ray 14 dataset. Model interpretation. To interpret the network predictions, they also produce heat map to visualize the area of the image most indicative of disease using cross activation mappings, like this. Show several examples of CAMs on the pneumonia detection task, as well as the 14 class pathology classification task. Conclusion. Pneumonia account for a significant proportion of patient morbidity and mortality. Two-thirds of global population lack access to radiologic diagnostics, according to an estimate by WHO. They develop an algorithm which detects pneumonia from frontal view chest X-ray image at a level exceeding fatiguing radiologist. They also show that a simple extension of our daily algorithm to detect multiple diseases outperforms previous state-of-the-art on chest X-ray routine. The largest publicly available chest X-ray dataset. With automation at the level of experts, they hope that this technology can improve healthcare delivery and increase access to medical imaging expertise in the world where access to skilled radiologists is limited. Actually, it is quite old paper about image classification in healthcare. They conducted research with good data, which is thought to be a reliable result. I think this paper, which has become the milestone of medical research using deep learning. Recently, there have been many studies using VGGNet, RASNet, and AlexNet models, and research topics also are extending. Thank you for listening.
Okay, hello guys. My name is Dong-Seok Kang, and I'm in team number 2, and my subject is supervised learning in big data seminar. And the paper I refer to this time is referenced by more than 8,000 times, and which the name is the YOLO version 3 and incremental improvement. And the keywords this paper is YOLO, CNN, and the classification supervised running. The supervised learning is a system called the YOLO for computer to recognize and classify objects. So I'm planning to introduce YOLO to you guys today, and I will introduce a project using a YOLO. The purpose of this paper is to refer to investigated classification and YOLO, one of the supervised learning technologies. And supervision, or such as a supervised learning project, is called out using YOLO version 3, useful for the classification. And project video is a demonstration of an unmanned payment system that calculated total amounts by calculating the price and the quantity of fruits through a camera installed at a counter when a customer chooses the fruits. The concept of the supervised learning is the literally learning data using data with an answers, and giving an input value like an X data, they are taught by giving a label like an Y data for the input value. And there is the typical classification and the regression problem. So for example, like a YOLO and the network architectures. And the concept of the classification is referred to a problem of classifying the given data according to a set categories like a label. And there are binary classifications such as yes or no classification, or the multiple classification classified into 2 or more categories such apple, banana, and the grape. And the last concept of like a regression is the problem that the predicts the continuous value like at graphs based on the feature of certain data and is mainly used to predict certain patterns and trends. In other words, the answer is not exactly 1 or 0 like the classification, but it can be predicted by any number like float. So this is a kind of future shopping mall. It is an unnamed payment system that detected fruits sold a camera inserted in the counter when the customer select the fruits and the places in on the counter, and calculates the total amount suitable for the current fruit price and allows the customer to pay immediately. Well, our frame image, like on one batch side, transmitted through the camera, are put into the run object detection model and matched with the result and the fruits, the information imported from Excel and transmitted to the web page. Then the detected fruits are displayed on your cart and they inform the total price, and the user proceed with the payment through the web screen. There okay. There's a 4,005 photos were used to detect the fruits, and about the 20,000 black boxes were used. The boxes are displayed on the object desired for object detection prediction, and the blue box means the computer is to provide for object running, and the black box means the anchor box, like an anchor box that adjusts the TX and the TY so that a recognized object can be recognized as that provide the correct answers. And the second graph is in an object detections, the performance, like an accuracy of the model is mainly determined through means average, the perception, which aka the MAP. The YOLO has so the conclusion of this paper is YOLO has the higher prediction and accuracy and the faster processing time than other predictive models. So the concept of MAP is in object detection, the performance. The higher the MAP, the more accurate it is, and the smaller it is, the more inaccurate it is. The package in number 1 are the entire codes for the project I just saw the previous video. The code in package number 2 is to place a lore in operating the entire codes in package number 1. And number 3 means that wrote YOLO, and we wrote the version number 3, and the class number 4 certain a list of the fruits needs for the supervised running and answer to the colors in the fruits. The box, the number 1 is the contain a kinds of the answer sheet that the store fruits, the item using the supervised running. The cause executed. The part number 2 is to create a box that recognized the fruits around the fruit shown in the picture on the left and calculate the position value of the box predicting the fruits and draw the box. After then, the predicted label like an Y value for the fruits and the confidence for the label are calculated. Okay, the box number 1 is service counts the numbers of the recognized fruits. With this work, the computer can know the exact number and price of the recognized fruits. So this provides running algorithm, and the area is not limited to fruits and can be applied up to larger marts and like a bigger marts and like an E-Mart or the Walmart and the convenience stores. This can serve the problem that can occur when a person works, such as high labor costs and crimes. Furthermore, it is expected that there will be an advantage in terms of the maintenance compared to existing the unmanned system, like a barcode, RFID, etc. Okay, my presentation is done, and thank you for listening.
I will review the paper, A Value of Civic Voices for Smart City, a big data analysis of civic queries posed by Seoul Citizen. The review will proceed in the order of introduction, method, analysis result, and conclusions and limitations. First is the introduction. As urban problems become more complex due to rapid urbanization, interest in smart cities that can efficiently solve this problem is increasing. Smart cities and big data related research are topics that are being actively studied in the field of public administration, urban engineering, and information science. In particular, efficient and scientific analysis of the vast amount of civil complaint data accumulated through various channels and methods enables finding solutions to urban problems. The importance of smart cities is not only in owning the technology itself, but also in leveraging technology in new approaches to solve problems, improve the quality of citizen life, and optimize government performance. Existing smart city related studies have urged that a reliable data sharing platform and how to use data can determine the success or failure of smart city. The author tried to propose a process for efficiently classifying and analyzing civil complaints data using machine learning and deep learning methods based on the civil complaint text data of Seoul citizen. Next is the data pre-processing part. The data used for the study are text data of a total of 160,316 civil complaints accumulated in OTMI from 2006 to 2017. The data consists of 13 columns such as title, username, and complaint subject category. A total of 16,821 cases were manually labeled for the subject categories of the civil complaint data based on the 13 administrative field categories defined in the Information Support System Guide. There are 10 categories of complaint topics used. The actual analysis. For examples, health, economy, transportation, culture, taxes, safety, women, housing, environment. The author removed personal information related data in the pre-processing stage and conducted morphological analysis using MICAP library. In addition, new words and compound nouns were added to the word dictionary for efficient analysis, and stop words such as referential pronouns and duplicate words were removed. Also, 8,238 training data and 90,574 test data were used for analysis by removing data less than 20 words. Next is method part. The author used Word2Vec, TF-IDF, random forests, and dynamic topic model in the paper. The analysis process consists of two major steps. First, after embedding the civil complaints data with Word2Vec, the author predicted the subject category of 90,574 civil complaints data by running 8,238 data with the random forest algorithm. Tenfold cross-validation was used for the model evaluation, and classification accuracy was found to be 70%. Second, the author attempted additional analysis using the dynamic topic model for the transportation, environment, and culture categories, which account for the largest proportion of categories. At this stage, the author collaborated with the Seoul Digital Foundation and the Seoul Big Data Police Office to derive the optimal topic that best reveals the problem of category extinction. Next is analysis result part. I will introduce only one example of the three categories of analysis results. First, the transportation topic was centered on complaints related to people who were excluded from transportation services. As time passed from 2006 to 2016, complaints related to safety and accident increased, and specific keywords such as blind person and traffic lights appeared. This suggests that civil complaints related to transportation are directed at the socially disadvantaged, such as the visual impaired and children. The environmental topic was centered on complaints about fine dust and energy saving. In particular, the keyword for fine dust showed a tendency to increase over time from 2006 to 2016. This suggests that Seoul citizens are paying attention to environmental issues such as fine dust, and citizens are paying attention to renewable energy among various fine dust reduction technologies. The culture category showed citizens' dissatisfaction with cultural properties and history. In particular, keywords for Gwanghwamun occupy a high proportion, and this context, it is necessary to strengthen the image of a Korean cultural asset through improvement of the Gwanghwamun area. Finally, conclusions and limitations. This paper proposes an analysis process for a smart city using text data of Seoul citizens and various methodologies to improve the quality of citizen life. The author argues that each civil complaint is related to at least one social problem, so the demands of citizens have policy implications. In addition, the author argued that the analysis needs to expand it to unit such as adjectives plus nouns and adverbs plus verbs in future studies, because noun-centered word analysis is mainly used for text analysis. A personal technical critique of this paper is as follows. First, the 10 classification categories used for analysis in this paper have class imbalance problems, so it is necessary to increase the proportion of the labeled training data. Second, it seems more appropriate to use the F1 score rather than accuracy as the evaluation metric for the multi-class classification task. Third, if a language model such as Transformer is used, higher classification accuracy can be achieved without using an embedding method such as word2vec. Thank you for listening to my review. In this section, I will leave the sentiment classification code using the Cobalt model. But bidirectional encoder representations for transformers developed by Google is a language model that bidirectionally pre-train natural language. Transfer learning using bots opens the area of a new language model beyond the performance of existing technologies. Today, I will review the code for classifying human emotions using CodeBot, the first Korean language model developed by SKT Brain. The model, code, and data sources are as follows. The theoretical contents of BERT requires a lot of background knowledge, so it is recommended that you study it personally. In this review, I will focus on the use of the model. First, mount Google Drive and clone get with the model you want to use. Next, in the Colab environment, move the path as follows and install the necessary libraries. One thing to note in this step is you must restart the Colab kernel after downloading the library. From now on, I will proceed with the code review in earnest. First, import the required library and set the path where the data is located. Next, fix the seed value and define parameters. These parameters have been prepared for code review in advance. Next, we load both model, tokenizer, and dataset. The dataset used in this code review is as follows. AI Hub creates various text and image dataset necessary to utilize artificial intelligence technology and provides them as public data. This data was created for the purpose of constructing emotional conversation data for artificial intelligence. Data consists of columns such as age, gender, uh, context keyword, uh, human sentence, and system response. Here are some simple data pre-processing steps. In this step, remove two misclassified rows, initialize the index, and replace the non-values with blank. After merging human sentences, only the column to be used for the learning are selected. And labeling coding is applied to the emotion classification column as the target column. Checking the sentence of the pre-processed data is as follows. If you check the target distribution of the train set and the test set, there seems to be no class imbalance problem. Here is the code to look at the basic statistic for the words. Based on this statistic, I determined the parameter values set above. The following is the part that pre-processes data in the form of input to be used in the covert model. The BERT model requires three inputs: token, mask, and segment. The token is a tokenizer used when training the BERT model, which tokenizes the data to be used for fine-tuning. And since the mask has a different length for each sentence, padding is applied to sentences that are less than the sequence length defined above. Also, segment is a pre-processing that mark the end and start of a sentence. To do this, we call tokenizer defined above and creates empty list to hold the token, masks, and segment. Next, it loops through the data through the for loop and creates token, mask, and segment for each sentence. It also stores target values in a separate list and converts tokens, masks, segments, and target into a NumPy array. The load data function is the function that executes the convert data function defined above. In this way, we create training and test data to be input to the model. The following is the code that defines the model structure to be used for the training and performs fine-tuning. First, convert the token, mask, and segments processed above into TensorFlow tensor type. Next, define the model and optimizer. Define the model structure as follows and compile it. In general, when performing fine-tuning, dropout is applied to the last layer of the pre-trained model, and then the layer is defined according to the class of data to be used. The number of classes of data used in this code review is 6. So the softmax function is used for the last layer. If it is a binary classification problem, you can use the sigmoid function. Next, define the model name, callback to prevent overfitting, and a checkpoint callback to save the model weight, and then proceed with training. In my Colab environment, the learning took about 30 minutes. A total of 10 epochs of training were performed, and there was no performance increase in the validation set. So the training was terminated at 5 epochs, and the training accuracy was about 0.08, and the validation accuracy was about 0.70. Finally, after loading the model weight with optimal validation accuracy, predicting the test set and analyzing the F1 score showed an F1 score of about 0.70 for the test set. Interestingly, it was found that the emotion that the model discriminated best was joy, and the emotion that the model did not discriminate the most was wound. This concludes my review of the COBOT multi-class classification code. Thanks.
Hi everyone, my name is Yoon Sun. Today my presentation topic is supervised and unsupervised reinforcement learning. First, today I introduce using unsupervised learning of one paper. This paper title is Using Twists to Assess Mental Well-being of Essential Workers During the COVID-19 Pandemic. The COVID-19 pandemic has led to large-scale lifestyle change and increased social isolation and stress on a societal level. This has had a unique impact on U.S. essential workers. And this paper examined the use of Twitter by essential workers as a step toward understanding the pandemic's impact on their mental well-being as compared to the population as a whole. And this paper has several keywords. First is social media, mental health, sentiment analysis, essential workers, and COVID-19. Before introducing this paper, we need to talk about essential workers. Essential workers means working outside of the home, increased stress, lifestyle change, social isolation, etc., and increased physical mental health risk. And next is literature. This paper has several important literature. First is previous work showed that users who display depression signs tend to be more active during the evenings and nights due to sleep disruption. Second is essential workers have reported higher levels of stress, anxiety, and tiredness, perceive lower feelings of control over their lives, and are least likely to engage in proactive coping. And this paper has no research question. And this paper used sentiment analysis. First, this study collected 2 different Twitter account samples, analyzed public tweets from over 4,000 accounts, over 4,000 accounts, 1,500 essential worker accounts, and 2,300 randomly selected US Twitter accounts. So how did you collect the essential worker account? In this study, sample essential worker accounted based on self-authored tweets that included "I am an essential worker." Then, using the following Python package, tweetp2, 50,000 tweets accounts were crawled using COVID-related keywords. COVID-related keyword is coronavirus, corona, and COVID-19. In addition, we collected tweets and comments for essential workers and random Twitter accounts from January to September 2019 and compare changes in each group over time. And now looking at general Twitter use during the pandemic, both group tweets in higher volumes than they had before. However, essential workers consistently post fewer tweets than average user both before and during the pandemic. Overall, average Twitter users saw an active period early in the day, whereas essential workers are active later at night and in the evenings. This trend was consistent both before and during the pandemic. And while past work suggests some connection between this late night activity and depression symptoms, this also could be due to their work schedules or other job-related factors at this point in time. Following our sense of what analyzed tweets specific to COVID-19 related topics showed lower sentiment scores than general topic tweets for both groups. And looking at the tweets topic, combined essential workers posted tweets with more positive sentiment than average user. And this consistent both before and during the pandemic, which is against what one might assume for a very difficult period of time. Now, at this stage, we cannot confirm why this is the case, but it could be related to some of the personal characteristics of essential workers of the types of jobs that they hold they lead them to present more positively online. And looking at keywords or the type of topics that people are posting about, average Twitter user posted a higher ratio of tweets with pandemic-related keywords, things like pandemic, coronavirus, mask, and risk, etc. Whereas essential workers posted a higher ratio of tweets with mental health-related keywords. So things like stress, sad, depressed, anxious, and struggle, etc. So this gives us some look at the type of topic. Look at the type of topics. These users are most interested in sharing assets, as well as some of the potential concerns they may have that they spill over in their online content. And next is discussion and limitation. This paper gives two discussion and two limitation. First discussion is this paper see difference in when they tweet, how often they tweet, and the sentiment behind their tweets. Second is why are essential workers may author fewer tweets than the average user. Their tweets are more likely to include mental health topic and include more positively associated content, both before and during pandemic. And the work sheds light on the well-being stage of essential workers, but cannot yet tell us the whole story of what has been a very stressful period of time. So in future work, this paper need to focus on some of the difference within essential worker. And second is this paper need to refine our method to invert different job categories from their online profiles, as well as use a more precise sentiment analysis to help explain what it is that's driving some of these initial findings. Thank you for your listening to my presentation. And if you have any question, please do free to ask me or send an email to me. Thank you.
I'm Hyung-Yong. Next, I will start my presenting. Although the current supervised learning technology has achieved great success, it is worth noting that due to the high cost of the data labeling process, it is difficult to obtain strong supervision information such as all choice levels for many tasks. The development of unsupervised learning is slow because the learning process is too difficult. Therefore, it is hoped that machine learning technology can work in a weakly supervised state. Professor Zhou Zhihua of Nanjing University published a paper in January 2018 called A Brief Introduction to Weakly Supervised Learning, which gave a new trend and idea for machine learning tasks. What is weakly supervised learning? The article said that weakly supervised learning can be divided into three typical types. The first is incomplete supervision. Only a usually small subset of training data is given with labels while the other data remain unlabeled. Such a situation occurs in various tasks. For example, in image categorization, the ground truth labels are given by human annotators. It is easy to get a huge number of images from the internet, whereas only a small subset of images can be annotated due to the human cost. The second type is inexact supervision. Only coarse-grained labels are given. Consider the image categorization task again. It is desirable to have every object in the images annotated. However, usually we only have image level labels rather than object level labels. The third type is inaccurate supervision. The given labels are not always ground truth. Such a situation occurs when the image annotator is careless or wary, or some images are difficult to categorize. These are the concepts written by the author in this article. To make it easier to understand, I will use Apple as an example. On the left is incomplete supervision. That is, we can see that some apples are labeled and some apples are not labeled, and the labeling is not complete. The one in the middle is inexact supervision. For this situation, we can think of this as a bag. We only know that there are apples in it, but we don't know where the apples are or have many. This situation is called inexact supervision. The one on the right is inaccurate supervision. That is, suppose we have some apples, but some are incorrectly labeled as pineapples. Then we call it inaccurate supervision. We will treat these types of weakly supervised learning separately, but it is worth mentioning that in practice, they often happen at the same time. Figure 1 provides an illustration of the three types of weak supervision that we will discuss in this article. Bars denote switcher vectors. Red blue marks labels. Question mark implies that the label may be inaccurate. Intermediate subgraphs depict some situations with mixed type of weak supervision. In order to solve incomplete supervision, we can consider two main techniques: active learning and semi-supervised learning. One is human intervention and the other is without human intervention. In order to solve inexact supervision, we can consider multi-instance learning. In order to solve inaccurate supervision, we consider noise learning. Let's talk a little bit more specifically about the methods listed above. First of all, in order to solve incomplete supervision, we consider active learning. This method involves manual intervention during the training process. The input is some labeled data including x, y, and unlabeled data only x, and the output is y or n. Consider the simplest binary classification problem. First, we train the labeled data and then we cluster the unlabeled data based on the experience gained. Active learning hypothesis can query ground truth tags of unlabeled instances from Oracle. Among these unlabeled data, active learning attempts to select the most valuable unlabeled instances for query. The most valuable refers to information and representativeness. The goal of active learning is to minimize the number of queries. Next, let's look the second technology to serve incomplete supervision, semi-supervised learning, which has no human intervention, as shown in the figure below. If we know that one data is positive and the other is negative, and there is a test data in the middle of the two data points, it is difficult for us to judge whether the test data is positive or negative. But if we are allowed to observe the description of some unlabeled data, then we can still be more certain that the test data is positive. In order to serve inexact supervision, we can consider multi-instance learning. In fact, almost all supervised learning algorithms have their multi-instance. Each data in the training dataset is regarded as a bag. Each bag is composed of multiple instances, and each bag has a visible label. In the example above, assume that the size of the bag is 8 by 8. If we use image bag generators with a size of 2 by 2 to obtain the instance, then we can get 16 instances. Obviously, our bag is labeled left picture. Tiger, every instance in the bag is unlabeled. Multi-instance learning assumes that every bag must have at least one key instance. This means that if the key instance in the example is example 9, then the label of this bag is positive. The process of multi-instance learning is to analyze and predict the bag and its multiple instances through the model to obtain the label of the bag. Multi-instance learning widely exists in the real world, and its application scenarios are very wide. Finally, to serve in accurate supervision, we can consider learning with label noise. In practice, the basic idea is to identify potential misclassified samples and then try to make corrections. For example, we use the method of data editing to build a relational adjacent table. Then we judge whether a point is suspicious. We judge whether this point is the same as the adjacent point. If it is the same, then this point is not suspicious and will remain as it is. If this point is different from the adjacent point, then this point is suspicious and this point will be deleted or remarked. Supervised learning techniques have achieved great success when there is strong supervision information like a large amount of training examples with ground truth levels. in real tasks. However, collecting supervision information requires cost, and thus it is usually desirable to be able to weekly supervised learning. This article focuses on three typical types of weak supervision: incomplete, inexact, and inaccurate supervision. Though they are discussed separately in practice, they often occur simultaneously. More and more researchers have recently been attracted to weekly supervised learning. Weekly supervised learning is extensive and has many application scenarios. Nevertheless, no matter what kinds of data and tasks are concerned, weekly supervised learning is becoming more and more important. Thank you.
안녕하세요. Valuable Civic Voice for Smart City, a big data analysis of civic queries posed by Seoul Citizen에 대한 크리틱스를 맡은 강동기입니다. 우선 해당 논문을 발표해주신 강상규님께 왜 이 논문을 선택을 했는지 물어봤는데요. 사회에 기여할 수 있는 논문이라고 생각해서 선택하였다고 들었습니다. 저도 지식의 욕구만을 채우는 것보다는 실제 사회에 좋은 영향을 줄 수 있는 논문이 중요하다고 생각하는데요. 해당 논문은 시민의 민원, 제안, 문의 등의 실질적인 데이터를 분석하여 이를 발전시켜 시민 중심의 도시를 계획한다는 것에 목적을 두고 있습니다. 현실에서는 소수의 대표자의 판단과 이익 아래 민주주의 정책들이 실현되고 있는데요. 이러한 한계성을 보완하여 철학적으로 이상적인 민주주의 가치를 과학적으로 접근한 좋은 논문이라고 생각됩니다. 해당 논문은 공공 데이터로 좋은 데이터를 사용하였으며 카테고리별로 자세한 분석과 예시를 들어서 이해하기가 편한 논문이었습니다. 다만 헤비 유저의 입력에 대한 데이터 분석은 따로 고민해 보아야 할 것 같습니다. 현재는 지도학습을 사용하여 분석되었지만 딥러닝을 이용한 비지도학습을 사용하여 분석을 한다면 현재뿐만 아니라 변화하는 문제에 대한 예측이 가능할 것 같습니다. 해당 논문은 2017년까지의 데이터를 이용하였는데 그 이후의 분석이 이루어지고 이를 활용한다면 이러한 데이터의 분석이 실제 도시 문제를 해결하고 시민의 삶의 질을 향상시키는 데 기여할 것이라 생각이 듭니다. 감사합니다.
네, 안녕하세요. 저는 A Brief Introduction to Weakly Supervised Learning 논문에 대한 비평을 진행해 보도록 하겠습니다. 머신러닝, 딥러닝 방법론은 다양한 작업, 특히 분류 및 회귀와 같은 지도학습 태스크에서 큰 성공을 거두었습니다. 하지만 이러한 방법론은 레이블링된 큰 훈련 데이터를 필요로 합니다. 레이블링된 데이터를 확보하는 것은 큰 시간과 경제적 비용이 들기 때문에 저자는 위클리 슈퍼바이즈드 러닝에 대해 현재까지 진행된 연구에 대한 전반적인 소개를 해주었습니다. 먼저 본 논문을 보며 접해보지 못했던 위클리 슈퍼바이즈드 러닝에 대한 전반적인 연구 동향에 대해 살펴볼 수 있는 좋은 기회였던 것 같습니다. 만약 위클리 슈퍼바이스드 러닝에 대한 연구가 확장되어 슈퍼바이스드 러닝의 버금가는 퍼포먼스를 보일 수 있다면 다양한 분야에서 유용하게 활용할 수 있을 것 같다는 생각이 들었습니다. 다음으로는 과연 연구가 계속 진행된다면 위클리 슈퍼바이스드 러닝이 잘 정제된 데이터를 활용하는 슈퍼바이스드 러닝과 비슷할 정도로 성과를 낼 수 있을까 하는 생각이 들었습니다. 개인적으로는 풀고자 하는 문제와 관련된 타당한 데이터를 수집하고 정제해서 관리하는 작업이 문제 해결에 있어 가장 중요하다고 생각합니다. 하지만 향후에 위클리 슈퍼바이스드 러닝 관련 연구가 어느 정도까지 발전할지 궁금했습니다. 이상으로 Brief Introduction to 위클리 슈퍼바이스드 러닝 논문에 대한 비평을 마치겠습니다. 감사합니다.
네, 안녕하세요. 저는 팀 넘버 2의 강동섭입니다. 저는 저희 팀 나윤선 학생이 발표했던 논문 Using Tweet to Access Mental Well-being of Essential Workers During the COVID-19 Pandemic에 대한 논문 크리틱을 맡게 되었습니다. 먼저 이 논문은 굉장히 흥미로웠어요. Essential Worker라는 재택근무가 허용되지 않는 꼭 이제 사회 필수 인력 혹은 이제 소매업자들이 겪는 그런 정신적 우울감 혹은 스트레스가 트위터라는 SNS에서 어떻게 사용성을 그렇지 않은 사람들과 차이를 보이냐에 대한 정신 감성적인 분석을 바더 형식으로 사용해서 표현하고 분석한 논문이었던 점에서 매우 흥미로웠었고요. 결과적으로 말씀을 드리자면 그런 에센셜 워커들이 그렇지 않은 사람들에 비해서 주로 밤 시간대에 트위터를 사용하고 게시물도 더 많이 올리고 그리고 가장 의외였던 요소 중 하나인 좀 긍정적인 표현을 좀 많이 했다는 부분에 대해서 좀 새롭게 알게 된 사실이자 이 논문을 좀 더 흥미롭게 크리틱스를 할 수 있게 만들어준 요소라고 생각을 합니다. 몇 가지 아쉬웠던 점에 대해서 이제 설명을 드리자면 먼저 이 에센셜 워커에 대한 분류가 좀 더 세분화가 되면 좋겠다라는 생각을 했습니다. 지금 이 논문상에서는 카이 논문에 이제 투고가 되었지만 카이 논문 특성상 이제 완성이 되지 않아도 일단은 1차적으로 투고가 가능했던 점을 활용해서인지 세분화가 이렇게 자세하게 이루어져 있지는 않더라고요. 예를 들면 에센셜 워커들의 이제 뭐 성별 혹은 이제 뭐 연령 혹은 에센셜 워커들의 직업군에 대한 세분화도 이루어진다면 조금 더 재밌는 연구가 될 것으로 기대를 하고 있고요. 그리고 두 번째로는 그 VAR-DER이라는 이제 정신감석 분석 툴을 이용을 했었는데 이제 크게 이 논문에서는 포지티브적인 부분만 분석을 했던 것으로 보여요. 그래서 좀 부정적인 표현이라든지 혹은 중립적인 표현을 한 에센셜 워커들에 대한 분석도 이루어지면 조금 더 풍성하고 재미있는 논문이 되지 않을까 생각을 합니다. 제 크리틱스는 이상으로 마치도록 하겠습니다. 감사합니다.
안녕하세요. 저는 팀2 나윤선입니다. 저는 이번 크리티크 영상으로 강동섭님의 욜로 V3에 관한 논문에 대해서 크리티크 영상을 준비했습니다. 먼저 본 논문은 머신러닝의 지도학습 중 하나인 욜로3 방법에 대해 공학적으로 설명한 논문입니다. 욜로3에 관한 논문과 더불어 욜로3를 사용하여 과일 이미지를 탐지하고 탐지한 과일 개수를 체크해서 계산하는 코드도 함께 첨부해 주었습니다. 저는 이러한 발표를 통해서 욜로3에 대한 개념과 성능에 대해서 알 수 있었습니다. 하지만 동선님에게 한 가지 궁금한 점이 있는데 현재까지 욜로는 욜로5 버전까지 나온 걸로 알고 있지만 왜 욜로3 버전을 사용하여 코드를 작성했는지에 대해서 궁금했습니다. 제가 생각한 답으로는 욜로3까지는 욜로 회사에서 개발하여 직접 배포하였기에 보다 불순물이 첨가되지 않고 정확한 클래시피케이션을 할 수 있었기에 아마 동선님도 욜로3를 썼지 않았을까라는 생각을 했습니다. 끝으로 저는 본 논문과 코드를 본 뒤에 이후 윌마트, 이마트 등 인공지능 샵에 대한 함의를 줄 수 있을 거라고 생각을 했습니다. 감사합니다.
안녕하세요. 저는 팀2의 조향영입니다. 저는 저희 팀원이 발표하신 체익스넷 레디올로지스트 레보 너모니아 디텍션 온 체스트 엑스레이스 라는 논문을 흥미롭게 읽었습니다. 미국에서만 2017년도 기준으로 매년 100만 명 이상의 성인이 폐렴으로 입원을 한다고 합니다. 그 중에서 5만여 명은 사망을 하게 된다고 해요. 전에 흉부 엑스레이 검사는 폐렴을 진단하는 최고의 방법이라고 여겨져 왔습니다. 그리고 이 연구에서는 흉부 엑스레이를 통해 폐렴을 진단할 수 있는 알고리즘을 개발했습니다. 이 연구에서 사용된 알고리즘인 체엑스넷은 현재 공개적으로 사용 가능한 가장 큰 흉부 X선 데이터 세트인 체스트 엑스레이 14에서 훈련된 121층 컨볼루션 신경망으로 14개의 질병에 대한 10만 개 이상의 정면 보기 X선 이미지를 포함합니다. 4명의 방사선 전문의가 테스트 세트에 주석을 달았으며 체엑스넷의 성능을 방사선 전문의 성능과 비교해봤을 때 이 연구에서는 체엑스넷은 성능 면에서 방사선 전문의를 능가한다는 것을 발견했습니다. 하지만 본 연구는 몇 가지 한계점이 있는데요. 첫 번째는 진단할 때 영상의학과 전문의와 모델에게 정면 방사선 사진만 제공을 하였다는 겁니다. 하지만 선행 연구에 의하면 정확한 진단을 위해서는 측면 보기 방사선 사진도 중요한 것으로 필요한 것으로 이렇게 나타났고요. 또한 모델이나 방사선 전문의 환자의 병력을 사용하는 것이 허용되지 않았습니다. 이는 흉부 방사선 사진을 해석할 때 방사선 전문의 진단 성능을 감소시키게 됩니다. 이상은 제 크리틱스 부분입니다. 감사합니다.